Good morning, ladies and gentlemen. My wife is worried about the title of my paper, that it's too long, and you may all fall asleep before you finish reading it. The title actually means that everything in this presentation is aimed at producing durable concrete structures, where durability is most needed, and that always means the cover zone. My main focus will be not on the concrete structures, but on the structures of formwork and reinforcement into which the concrete is poured. I want to take you inside these cages to help you appreciate the problems faced by the concrete workers. These problems are mainly about access. Access for concrete, access for vibrators, and access for workmen, so they can do all the things listed here without too much discomfort. Finally, there has to be access for light, so that the flow of the concrete can be observed, even at the bottom of the pour, and particularly as it forces its way through the outer Rio bars and into the cover zone. Problems occur when concrete doesn't flow. It has to flow from the pump down to the bottom of the pour, then along the bottom, around all obstructions, through the gaps in the Rio bars and into the cover zone. The challenge is to get concrete into a cage like this so that it drops cleanly to the bottom and then spreads outward and upward, filling all intended voids, and particularly the cover zone between the outside reinforcement and the forms. The white wavy lines indicate how the surface level of the cover concrete rises progressively as it is forced out through the available gaps in the almost solid wall of reinforcing bars. Problems arise when this doesn't happen, as in this big foundation plinth. So what happened here? It looks like a cold joint where the bottom layer lost its capacity to flow before the next batch of concrete was placed on top. But this disaster could have been prevented. And how do we know that the good concrete is really as good as it is supposed to be? Now here's another problem. The problem's in Pier X, not in Pier Y. It was the designer's fault in the first place. See how the throat bars in Pier Y stop short enough to provide some sort of access? However, in Pier X, the throat bars extended full length and blocked off all access, even for pump hoses or chutes. It's difficult to control a vibrator when operating only from the top of a tapered column like this one. The designer's detailing for the throat bars was a major cause of the failure. Nevertheless, it was still gross carelessness on the part of the contractor. He's supposed to prevent such problems, even when they are caused by the designer. One way to overcome such a problem, without requiring a design change, is to use self-compacting concrete. As